Nagarajan. I like open source both for contributing as well as consuming. I am part of 3 different teams. Our Technologies. At Our Technology, I was the CTO. So it's basically a training and consulting company. And apart from that, I am a founder and I am part of Tech Park. Thank you. So I'm part of this Tech Park initiative where we help deserving candidates, particularly from rural Tamil Nadu, school kids and all those stuff. So we help them to find their job by providing free training and all those stuff. So this is another initiative that I'm involved in. And apart from that, the initiative that I'm really proud about, and I'm privileged to be part of Bangalore Java User Group, which some of you may be aware of. We are one of the long-running Java User Group at Bangalore. We used to conduct a lot of meetups regularly, and then we share knowledge on data engineering, later things in Java. But today my talk is more related to the kind of research work that we do in Bangalore. Apart from providing meetups, we also encourage open source. In fact, I myself create certain open source project as a research project. The project that I'm going to show you is one of that. So it's going to be about, this is a research project, but it's more about, our talk today is about the area that we are going to work on this. So we go to this. So we all know that the importance of data. Data is king. So if data is king, the place that the king resides, that is database, is supposed to be balanced. So we need to give that much of importance, sophistication for databases that we give. But then people who are in palace, they are supposed to be very, very powerful. That is database developers. But whether they are very powerful or not, that only history will tell. Ideally, they are supposed to be powerful, but the kind of framework choices that we have taken over the year, they hide their importance. So you see the approaches so far. So to keep it from a data engineer's perspective, most of the time we need to interact with relational databases. In fact, MySQL, Postgres, or any relational database. Particularly if you are thinking about a large-scale enterprise application which is developed 10 years before, most probably you will be having Postgres, MySQL, or this kind of relational databases. So relational database is something that we cannot escape. But so far, our approaches, I'm talking about these approaches that we are talking about came way before data engineering came to the industry. So these are all the approaches. The right time to ask question is the time that you get the question. So you don't need to wait till the end. So basically you have a database. On the bottommost layer is JDBC. Whichever route that you come from, they are like a traffic signal. You need to go through them only. They are single gateway. But people hate writing direct JDBC code. It's as if like pointers in C. They are very powerful, but people don't want to do pointers. Same way, JDBC is very powerful, but we don't want to use pointers directly in our application code for all the maintenance and the complexities. So we will not go to the main problem in our industry is first we will go to the tools directly. We will not go to the tools directly, but rather we will go with an approaches. So there are 2 approaches at the very, very high level. In fact, if you are from banking industry, if you are developing a software which is developed some 20 years, 15 years before, most probably you won't be using either Spring JDBC or JPA. Is there anybody who is not using Spring JDBC or Spring JPA? Any other custom JDBC mappers? But custom JDBC mapper was a norm earlier. And after that, now if you see the structure, JDBC mappers, that is SQL mappers, see the database access from the perspective of database developer. So basically database developer, all that they know is SQL. So they see the data access through SQL. You write an SQL and you give a mapping and then you access it. Whereas over the period of time, in fact, the SQL mapper came first. Before even Spring JDBC, there were a lot of other things like Torch, all the things were there in Apache itself, but they are included data. But after that, Hibernate came. Hibernate changed our industry once for all. In fact, many people are so religious about this API choice, even though they have serious limitations as we speak today in the current trend. So what JPA did is, they considered which side the complexity should reside in. We as a Java developer, are we familiar in SQL or are we familiar in Java? We are supposed to be familiar in Java. So they took the other side, where you map your tables as objects or classes. Tables can be considered as class or objects. Class. So row is object. The fundamental principle of JP, because later we are going to talk about the limitation, but before we go to that, we need to know where exactly the limitation is coming from. So this entire approach was taken with an assumption that you always consider your database as classes and objects. But over the period of time, database evolved so much, it's no longer about tables. Particularly if you are in Postgres world, you know, Postgres is going beyond just relational database. It's even an object-oriented database today. So one thing that we need to consider is there was no flexibility that is given to database developers when it comes to data access. So before we go to the next step, let us understand black and white of why are we supposed to use a framework or a tool. So these are all our major items that we want to take it from a framework or a tool. In case if I miss anything, please let me know. So one, like any development team, we want to write less, do more. And then we want to offload DB from a performance standpoint. We want to do validations, we want to do batch operations, optimize our queries, dialects. What do we use? Why do we need dialects? Exactly, portability. So dialects in a way that I want to change my database from MySQL to Postgres to Oracle. I want to keep my code same. So that's why we use dialects. And then cache. Cache is like, it's a two-way sword. We are not supposed to use cache as on today, we will see that later. But we will take a very simple perspective all throughout this year. This is all that we want to do, even though we have different approaches. We have queries. Database knows only query, like how browsers know only HTML, whether you are coming from PHP or Java, they know only HTML. Similarly, database knows only SQL. How you are going to form this query, pass it to the database, get the result, give it to your underlying language or platform, that is all that matters. So I am just taking from a JPA world. In JPA world, what happens is you mark them as, for example, JPA world today, it's certainly done by annotations. So we say that I need this as an entity, I need this as transactional, I need this as an HQL. So this is how we do it in JPA. Now let us see what happens behind the screen. Now, once you mark it, your engine, basically in a Hibernate world, you need an engine. In your case, it's basically JPA engine is Hibernate. So what Hibernate does is, during your runtime, if you are firing, say for example, you create an object and then save. What is the query that you need to fire? You need to fire an insert statement. So during runtime, it does all the reflection kind of stuff and then makes a query and then runs it. So it makes some magic there. Basically, it's an optimization that it does. But apart from that, during startup time, it makes your connection settings, connection tool, all the things. But point that we need to note here, which is very, very important if you really want to consider how future of this data persistence access is going to be. Everything that is controlled by runtime. This one word is very, very important if you are thinking seriously about cloud native applications. This is not just related to little out of context. Now, if you look at what is happening around us, whether in UI technologies or in server technologies, this is what happening. We used to develop applications with Spring Boot earlier, but now we are talking about something called Quartus. We used to develop React or Angular application, but we have a technology called Jamstack, static site generator on the UI. There is one point that connects all of them together. What is it? It's actually not cloud native. Cloud native is like, say for example, you have your own house. You will do whatever that you want to do at your own time. But you will use electricity based on your own convenience. But consider you are staying in a PG, what do you do? And you are staying in a PG where you currently share among your peers. Then you will be concerned about, okay, extra light should not go. What do I want to do it earlier on the daytime. So you will plan for efficiency. That's all about cloud native. Even though we talk about technically a lot of things, but it's all about this. You need to do a lot of your homework. When you go to cloud, do only what is required for your users. Don't do whatever that is needed for your daily work, like CI/CD. Doing CI/CD in cloud doesn't make much of a sense, which is now changing. So testing you don't need to do in your cloud. You can do it offline. So basically, you want to do everything right during your development, which means you want to do it at a compile time. Now we can just consider Quarkus case. In Quarkus case, Quarkus is cloud native. How it becomes cloud native? Because during your compile time itself, Quarkus makes your application as a native application, which means during runtime it simply executes. But in case if you look at Spring Boot perspective or any those frameworks, during your runtime there is the auto writing and all those, which is good in some cases still. But basically in cloud native case you build everything right up front. Similarly in Jamstack word or static site generator, whatever that you do rendering in Angular or React in the browser, they will do it right at the compile time. Now just take that inspiration to data access also. That is what we are going to talk about in a very simple sense. Before we go to the technical thing, we will just see, okay, these are the things that is happening on the technical side. Similarly, this relational databases also has gone through a transformational disruptive changes. And I just want to highlight certain points which is relevant to this. There are a lot of other points. Some of you are very familiar with relational databases than me, so excuse me, but I will just consider some of them that is relevant to this. Point number one, nobody can deny there were problems. In fact, 10 years before, we even called it as NoSQL movement. People were jumping out of relational databases, they were going to NoSQL DBs like MongoDB and all those stuff. They consider that basically NoSQL movement is also about going away from structure, because we don't like discipline when we are following it, but we need it only when we need it at the later point in time. So we consider that a structured DB where in a relational database, before you put any data, you need to tell that this is the contract type, this is my type, this is my relation, this is my constraint. So you put a structure and then you put the data. People really hate it because they found it like dynamically you cannot change it. So this is one problem that we consider, it's a problem. And then cloud readiness. Traditionally, relational databases are made for vertical scalability because when they were invented, there was nothing called cloud. At that point in time, vertical scalability is the main factor. What is vertical scalability? You are concerned about, if I'm including RAM, how much my software will be able to take advantage of. So you will add hardware on top of the same system, and that's how you design scalability. But today we live in a world, we no longer worry much about vertical scalability. I add more nodes because adding a node is very easy in cloud world. So we think about horizontal scalability. And by design, MySQL, Postgres, they were not prepared for this. In fact, there are some initiatives that is happening in Google, in Amazon, but still they were not cloud ready at that point in time. Now, we consider today, I'm just putting some of the databases, there are some other real great databases also, but I just took one each. If you look at enterprise, Oracle's 20C is way different than it was earlier because it's made for cloud. Our cloud standard, which is from Google, it's basically Postgres compatible database. And then Postgres today, they have even open source scalable items and CockroachDB. So these are built for cloud with all the horizontal scalability in mind. But this is the real strange part. Now if you look at the previous layer, we considered structured data as a limitation. But now you consider it's the same slide, only thing is the color is changed. Now we realize after we struggled a lot with unstructured database, people realize the importance of being disciplined, being structured in first place. So now we consider that structure is an advantage. Again, in technology, it's not like one thing that happens separately. It's a combination of multiple things. So I'm just comparing with what happened to the programming world. If you observe Python and JavaScript, we consider that it's basically a dynamic language. And people are going from Java or C# to those kind of languages. But now if you look at the latest version of JavaScript, latest version of Python, you see they give lot of importance for type safety. Now, industry has realized that type is safety. Now, considering that these are the things that has happened behind the screen, two different worlds, technically what has that happened. By any chance, we will change our approach, but unfortunately our approach even today remains almost same. So that is the problem that we are going to address now. If you look at it, there is only one small part that is different compared to the previous slide that we saw. What is that one new thing that you see? You see Juke here. So it's not, Juke is not new, it is there for quite some time. So what Juke does is, whatever that it wants to do, like saying a Hibernate, it actually compiles your database and then creates all the code during compile time itself. So it's like consider it's a native compilation. So after that, you don't need any engines to run your code, it will run with just plain simple changes. But Juke also has certain problems that we'll go through. And apart from that, just for the clarity sake, I'm just keeping one item away. There is also another disruption that is happening with projects like Hasura, all these things. They are very good, but they solve a different problem altogether. And you need to be very, and this is like, unfortunately many data engineers use that, but that we need to use it with caution. So what happens is, we as data engineers, we need data, we want to interact with relational databases either to get the data or write it to the database. It's from my own experience. I was working for a big retail company where I had my data coming from MS SQL, Postgres, all these different databases. Now I need my data. First and foremost, there's some principle, right? Don't repeat Drake principle. If you are using Drake principle, the architects actually said you need to use existing APIs to get the data. So we just followed our architects. We used existing REST APIs to get the data, to write the data. Now can you all guess what can go wrong here if I'm using APIs, REST-based APIs to talk to databases?
It's very chatty. Chatty.
Which one?
It's very chatty.
Yeah.
Stateless protocol.
More than that, it's like this. I, as a data engineer, where my data is available, it's available in my relational database. That's the place where all my data is available. And I need all the data, all the data that I need. Now, point number one, performance-wise I'm limited because you are calling through REST APIs. The encoding, decoding, all that happens. So, in a performance critical case, it will not work out. You are unnecessarily spoiling your API server. All that you need is already available in your database. Point number two, the APIs are written for application cases. It's not written for data engineering case. I want the data in the way that I want, with the amount that I want. So the quantity and quality is not guaranteed. So it's about limitation, performance, as well as the perspective that I have. So what we did is, we started writing our own queries. But then also we had problems. Because in certain cases, your databases are very, very sensitive. If you are an organization who is strict about GDPR and all those stuff, you will not even have access to it. Even you are in topmost position. So that made all the issues of approaching my data. So what was actually required for us is there any way that I can directly go to the databases in a safe manner without compromising on my performance and limitations to the perspective. That was the basic research that we started doing. Now, REST and GraphQL, there are some new solutions coming in. They have a different perspective altogether. You can use them for headless CMS cases, but using them for data engineering will not work out. Now, if you look at a very simple high-level perspective of what you want to do, select from movie where it is directed by so and so person. So, just from a programming perspective, this is what I want to do. So, I just want to say, I go to a store, I'm going to run a select, and then I'm going to call directed by, and it is list of numbers. With this simple mindset, we'll go to the demo and then I'll come back to this. Now, first, let us get an idea about how this compare and ORMs work. They are slightly different, so it will take some time to get this. So, we will see. In my case, I have my own research project that is SQL components, it's still in beta, but Juke is also another example. If you are coming from Rust, there is another diesel.rust is there. In Go also there is one SQL. So, typically here, if you look at it, this is all that I need to add. When you add this, it's like your Spring Boot plugins. So if you look at it, this is added under build. So now when you do a build, in my case, I have a MySQL database. I have no persistent logic code in my code. If you look at it, my source code, I have no code that is related to my persistence logic. This is my database. This is my database. If you are coming from banking industry, there is a famous document called the data dictionary. What is the data dictionary? Typically, in very sensitive industry, if your table is employee, it will not be named as employee. It will be something like EP, E1, all the things, just to make sure that nobody understands it. So, the data dictionary is what I put here. So, when I am talking about code generator is not just it generates a random code. So, this is the data dictionary document that we give. So, upon this document only, we look at the document, we write our implementation. Consider in this world, people who are going to look at it, it's your compiler. Compiler will look at it, rather than you do it, they will do it automatically. All that you need to inform the compiler. So in this case, I just kept it very simple. I just said that this is my database, and these are my auditing fields, these are my encryptions, this is my mapping and all those stuff. Now, just when you do compiling, what happens is, this compiler connects to your database, match your data dictionary, and then try to write the code in such a way a normal human being can write. Now it is now very successful. If you look at the code will not be part of your SRC, but rather it is, Dagger also does the same technique. If you go to target folder, you see this is the code. Now you can go and see the code yourself. It's well documented, security validated, check style validated, sonar validated, proper code that anybody can understand. Now if you look at it, where it gets a document. So you try to get maximum out of your database. As a database developer, if you have the habit of documenting your database, it will create the document all on its own. Now consider that it's all done now. It's done for only for once. Now let us look at how the daily routine is going to be. So let us look at this very simple case. So there are three categories. The current state of the project, actually when we started doing this project, we wanted to categorize this as three different audience from the simplicity sake. So first audience is data engineer, and that is the perspective that we see today. And the second set of audience is API developer, where you build your REST APIs around this. And the third is architecture level, where you think about performance, maintainability, upgradability, all the things. Now, considering compiler, basically this compiler, among all the other solutions, actually there are some other popular solutions also, but unfortunately these are all solutions that is available outside Java, but I really like these. So, from other language perspective, you can look at it for a reference. These are really good examples of. So, DSET is coming from Rust side. SQLC is for Go. If you look at CGGen, that is a Facebook open source project specifically made for C programming with SQL components, and Juke is for Java. So, they all follow the same technique only. But they all have some problems, that is what we are trying to address with this. So now all of them have a compiler, but what level of intelligence that you want to add to your compiler, that is the place where these tools will differ from each other. Now I put the compiler into three different categories. Point number one, type. In this case, now if you look at it, I have three movies and I want to insert, say for example, Spider-Man. You have movie store, and then in database, how do you insert the data? You call insert, you just say insert. And then how do you insert values? You call values. You put values. So now you want to include Spider-Man, you can put it here. But you cannot put some string or number. Compiler itself will stop here. So whatever optimization that this compiler will train to do is all done right at your IDE level. Now after this, okay, insert it. For example, Spider-Man. So this is about type. Type has a lot of other things also, but that is type. And now what is the second part that we want to consider? Sequence. What is sequence? Why sequence is very important? Particularly if you are thinking about SQL code. SQL has a grammar, right? Now you put values. What is the other possibility that can happen after one value? Insert into values. Next. You can put few more values if you want. Or otherwise, you can execute. It's executed. Now, I want to insert more than one. Insert values. I want to include the Jurassic Park. I want to include, say, Avatar. And then execute. Why? Because it needs list. Now, I want to print movie store, select, I want to print the number of movie. So after select, if you want, you can call count. insert perspective. Now, we go to the little complex cases. This is the place where sometimes we tend to forget about performance. It's all about managing that level of abstraction without compromising our performance. In a typical world, it's not just you are going to create something. You also need what is being created. For example, auto-generated idea and all this stuff. So you need something to return it. So for returning it, you just call dot return. Now if you look at the dot returning, actually third step is still in the environment, it is still experimental, but third is environment. So what is environment? Now when you call this returning, your intent is to get the value. If you look at the recent changes that has happened in Postgres, what has happened related to returning? Earlier, if you want to return the data, you insert the data and fire another query and then get the data. Now it is no longer required because it's a very common case. Particularly, this is very sensitive in terms of performance if you really look at this returning value. Postgres natively supports something called return. So this compiler automatically understands which version of Java that you use, which version of Postgres that you use, what type of database vendor that you use. It creates a query as per the actual underlying environment. Then it creates that. Now if you look at this, if you look at what is being created, look at the ID is there. And it is not with the additional query. The query is handled by Postgres with the native returning subprogram. Now, but this is from the creation of the data, but from the selection of the data, now all that I need, any database, I will just connect. Once I connect it, now I want to list everything by, say, directed. Directed is a string field. Now if I say directed by dot, you see equal to and like. But now I want it based on rating. Now if you put a dot here, you see greater than distance. So it knows every minute details of your database. Apart from that, you can also support the intelligence through your data dictionary files, and through that they generate this code. Idea is, if you really want to connect to your database, and due to time limitation I couldn't cover it, but on top of this, through data dictionary I can control security, I can control visibility. I can say, okay, for example, this data engineering team needs only these tables and need only these query access. You can give that, and wherever it is being encrypted or decrypted, you can give that, so that the developer side, data engineering side, you don't care about how the underlying implementation is. You just make a call, get it through Java, and then insert it to whatever that you want to inject. That's all. So this is from the functional perspective. Any questions?